Hey everybody, and welcome to a video on compound inequalities. Let's make it happen. So far, we've looked at all sorts of inequalities, just like the two in front of you. And before we begin, I'd like you to actually pause the video now. Please solve each of these inequalities and graph them on the number lines below. And when you're done, please play the video and see how it went. Alright, I hope that went well for you. Now so far, we've dealt with these two problems individually. In the first, we're looking for all the values of d that make 4d minus 7 less than 8 plus d. And in the second problem, we're looking for all the values of d that make negative 5d plus 7 less than or equal to negative 3. But what happens when we are faced with an inequality like 4d minus 7 is less than 8 plus d and negative 5d plus 7 is less than or equal to negative 3. Such an inequality is called a compound inequality. And what is a compound inequality? A compound inequality is when we have two or more inequalities with the same variables at the same time. In this case, to be a solution to a compound inequality involving and, the numbers, when substituted for the variables, must make all statements true. That is, the number has to be a solution to all of the individual inequalities in order to be a solution to the compound inequality. So that means when we substitute our number into 4d minus 7 is less than 8 plus d, it has to make that true, but at the same time, the number is going to have to make negative 5d plus 7 is less than or equal to 3 true as well. So how do we go about solving a compound inequality? Actually, it's going to be in much the same way that we did before with individual inequalities. We actually have to solve each individual inequality first. And we've actually already done that. But what we're going to do now is we're going to take both of these graphs of the individual solution sets and we're going to actually place them on the exact same number line. If we look at this graph, all the numbers that are colored blue are going to make this statement true. That is, all numbers less than 5. All of the numbers that are colored red are going to make this statement true. That is, all numbers greater than or equal to 2. So our question is, what numbers are going to make this compound inequality true? Well, the numbers that make both of the individual statements true. That is, numbers that are colored in both blue and in red. So let's shade those right now. So we can see right here in front of us, these are the numbers that are going to make both of those statements true at the same time. They're going to be the solutions to this and compound inequality. Now, it's really great to show our reader the solution set with a graph. It's also really nice to show them the solution set with a nice, succinct inequality. And this is how we write it. We want to write all numbers greater than or equal to 2, but also less than 5. And here's how it looks. And this is read as 2 is less than or equal to d, which is less than 5. And you can see that both of our individual inequalities from before are embedded within this final inequality of our solution set. A couple of other things. When we write these condensed and compound inequalities, we like to place our numbers from left to right on the number line. You can see that 2 is to the left of 5 in this inequality as it is on the real number line. So while in theory you could write this as 5 is greater than d, which is greater than or equal to 2, and that's a true statement, we tend not to write it that way. A few other notes about solving these compound inequalities. In general, it's really best to draw the graph first. It's so much easier to determine the solution set for a compound inequality from its graph than from the mathematical statements above. Another one. It's really important to draw nice long arrows on our number line. This way we can really see all the numbers that are solutions. Also, it's really important on a homework assignment or a test setting to shade the solution set. It's also really important to write down the solution set algebraically. That way the reader gets both a picture of the solution set and a statement of the solution set. If you have the ability to use colors, I often suggest color coding your math work so that it's easy for the reader to see what writing corresponds with which inequality as you see I've done here with blue and red. If that's not an option, no problem, just a suggestion. Here's a slightly different looking problem, and in this case, we are given a condensed inequality to begin with. And in this case, we need to recognize that this is an AND statement in disguise. And whenever we are presented with this kind of condensed inequality, the best course of action is to split the inequality into two separate statements separated by AND. In this case, we're looking for values of Q such that 12 is less than negative 3Q plus 4, and negative 3Q plus 4 is less than 28. Now, just like before, we're going to solve each of these inequalities individually, graph them on the number line, and find our solution to this compound inequality. So, why don't you pause the video now, give this a try, and when you're done, play the video, and let's see how it went. So, as you can see, I solved each inequality individually and graphed them individually on this number line in blue for the left inequality and red for the right inequality. And any number that was shaded in both blue and in red must make both of those individual statements true at the same time and is therefore part of our solution set to this compound inequality. And to write the solution set algebraically, we'll write this as negative 8 is less than Q, which is less than negative 8/3. Here's another compound inequality involving AND. And I'll tell you now, this one's going to be a little bit different from the ones we've seen so far. But still, I'd like you to pause the video now and give it a try. And when you're all done, I'd like you to play the video and see how it went. In this case, after solving each of our individual inequalities and graphing them on the same number line, we see that the two individual inequalities actually face in the same direction. Now, there are still numbers that are shaded in both blue and in red, and those numbers are still going to be the solutions to our AND compound inequality. So let's shade them in now. But in this case, it appears that this solution set is going to go on and on and on forever and ever and ever to the right on our number line. And so it appears to me that our solution set for this compound inequality is just going to be W is greater than or equal to 2/3. In this case, any number that made this inequality true already made the other one true, and so to write our solution set, all we have to write is W is greater than or equal to 2/3. Note, there's no fancy condensed inequality for this solution set, and sometimes students try to write fancy stuff when it's not really appropriate. This simple statement will do. One more example. Again, this one is going to end up different from all the other ones we've seen, but I'd like you to pause the video now, please give this a try, and when you're all done, please play the video, and we'll see how it went. In this case, after solving each individual inequality and graphing it on the same number line, we see that there are no numbers that are colored in blue and in red. That is, there are no numbers that make both of these individual statements true at the same time. In this case, we'd say that this compound inequality has no solutions. In general, if you're ever solving an AND compound inequality, if the two inequalities overlap nowhere, then the compound inequality has no solutions. Now, there's so many possibilities for what the outcome could be after you solve the individual parts of any compound inequality. So I want to take a brief moment to review all the different possibilities and what the solution sets are going to look like. In this case, we're going to use two fictitious numbers, A and B, and we're going to say right from the get-go that A is less than B. And in front of you, you've got 6 different possibilities that could happen when you have an AND compound inequality. Recall, in order to be a solution to an and compound inequality, you must be a solution to all of the individual inequalities. And what I'd like you to do is pause the video now and write in and draw in what you think the solution sets are going to be for all 6. And when you're done, please play the video and we'll see how it went. In each case, only the numbers that were shaded in both blue and red were solutions to the and compound inequality, and so you can see drawn and written in front of you the solution sets to all 6.